The critical concept that allowed chemical engineering to establish itself as a unique branch of knowledge, not simply an offshoot of chemistry, not simply an offshoot of engineering or a hybrid between the two, was the concept of unit operations. What are unit operations? Well, unit operations, in some sense, are the alphabet out of which the chemical industry builds itself. Generally, the European tradition in chemistry was an industrial chemical tradition. That is, they looked at the chemical industry, let's say horizontally. Here's how you manufactured paper from beginning to end. Here's how you manufactured sugar, glass, dyes, pharmaceuticals. And there was no clear recognition that all of these separate industries being worked in by industrial chemists had certain elements in common. These elements are called unit operations. There are things like, in all of these, there's mixing, there's evaporating, there's distillation, there's grinding. And the idea of unit operations is all of these use one or more of those unit operations, but they use different ones in different orders, but it's still the same basis, and it cuts across industrial lines. The idea had been suggested as early as the 1880s, 1890s by a British engineer, but it didn't catch on in Britain, and he didn't express it quite as implicitly as Arthur D. Little did in the middle of the 1910s when he was serving as chairman of the visiting committee looking at the combined departments of chemistry and chemical engineering at MIT. And it was in making his report that he introduced the idea of unit operations as a way to organize a chemical engineering curriculum and a way to distinguish chemical engineering from mechanical engineering, civil engineering, and chemistry. Essentially, he argued that it was the quantitative study of these unit operations and the machines that carried them out on a large scale that made chemical engineering different from what the chemists were doing. They weren't looking at machines, and they weren't looking at these physical operations, and what mechanical engineers were doing. And it was this concept of we're studying these different unit operations that can be applied to any chemical industry, organized in different ways, in different forms. That's what makes chemical engineering what it is. The idea is first applied to MIT's curriculum, and then under Little's influence and the American Institute of Chemical Engineers' influence, gets diffused from Little's work at MIT to Little's work through the AICHE to push this as a way to reorganize how chemical engineering is taught at all universities.